Hey everybody, Mr. Calbeck here. We're going to do a video to help you guys out on section 10.4. I know there's a couple of you that were asking for help on questions 19 and 20. They are quite a bit more challenging than some of the other ones because it requires you to remember a little bit more algebra. We did do algebra like this year, but it's been a while, and with distance learning, it's easy to forget stuff. So if you struggled with this, I'm sorry about that. Hopefully this will help you. And we're going to go ahead and jump in again. We're going to do 19 and 20 today on this video. So this is question 19. I've already drawn it for you. And what we learned in the video was that if you have an inscribed quadrilateral, remember inscribed means inside. So if you have a quadrilateral inside a circle, then that means opposite angles have to be supplementary. Okay? And we talked about why that is. Mentioned that the reason for that is when you have two angles, it actually makes up the entire circle. So this angle here, DCB, is an inscribed angle, and it covers this part of the circle, that arc. The other angle, DAB, covers the other part of the circle. So you actually get the whole circle with just two angles. And remember, inscribed angles are always going to be half the arc measure. So if both of these together give you the entire circle, then that means that they have to be half of the entire circle, or 180 degrees. Right? So that's what the video talked about. But let's go ahead and see what this looks like in terms of the actual math. That means that 26y plus 2x equals 180 degrees. And I'm hoping you at least got that far because that's what we kind of stopped with in the video. The problem is you have two variables. You can't solve this. You can't get an answer, or a number rather, for x or y. Here's the trick. Because there are two variables, you need two equations. And we need a system of equations in here, which means we need to do the other set of angles. The other two angles are also supplementary, which means they also add up to be 180 degrees. So that means that 21y plus 3x also equals 180. So that leaves us with a system of equations. Now, there's a bunch of ways to solve systems that you learned in Algebra 1. And I'm certainly hoping that you guys remember at least a little of that. But for this one, we're going to need to get, basically when you're solving a system, the most foolproof way is to get one variable by itself. Okay? So you guys can figure out what you would like to do with this. But for me, I'm just going to pick what looks like the easiest variable to get by itself. And so I would choose either the 2x here or the 3x here. I'll use the 3x just because it's on the bottom and then I don't have to rewrite everything. But both of those would be easy to solve. I wouldn't try to get the 26y or the 21y by itself because you're going to end up having to divide by 26 and everything, and you're going to get some ugly fractions. If you pick the 2x or the 3x, then you're going to have no ugly fractions. So I'm going to try that here. If I want to get x by itself, I just need to do the opposite. So I'm going to subtract 21y from both sides, which gives me 3x equals 180 minus 21y. All right, now we just need to divide. This is 3 times x. We're going to do the opposite. This is math we've kind of been doing all year. So we do the opposite of this, divide the entire thing by 3. Remember, the golden rule says, that what you do to one side, you must do to the other side. Right? You got to do it to the entire side. Try to remember that, which means that both of these get divided by 3. All right, so if I divide each of those by 3, I end up with x equals 180 divided by 3 is 60. 21y divided by 3 is 7y. Okay, and the fraction is gone because I divided it. Remember, fractions are just division problems, nothing to be afraid of. So that said, that's what x equals. These two things, remember the equal sign, really what that means is it means the same. It means the x is the same as 60 minus 7y, which means every time you see an x, you can replace it with 60 minus 7y. And I see an x here, so I'm going to replace that x with what x equals, with what x is. So this entire piece here, that's what x is. So I'm going to replace that x with 60 minus 7y. So it looks like this. You have 26y plus 2 times, remember the x is gone now. I'm going to replace it with 60 minus 7y. Remember to put that in parentheses or you're going to have a problem. And now we can solve this because we have one variable in it. So I have 26y plus 2 distributes into both of those. So that gives me 120 minus 14y equals 180. And we can combine like terms and solve this. So 26 and negative 14, that makes 12y. So I combine those. Plus 120 equals 180. We're getting pretty close here. I'm going to subtract, sorry, not divide. Subtract 120 from both sides. I get 12y equals 60. You can divide by 12 and you get y equals y equals 5. So, or y equals 6. Did I get that right? Yeah, y equals 5. Okay. So that's y, but that doesn't tell me what x is. However, you have two equations that relate x and y. So all you need to do once you find y is to plug it back into either equation and solve for x. I'm going to plug it into this one because the 21 is smaller than 26, so I like that number better. So again, I'm going to do the exact same thing I did with the x, but instead of replacing it with an expression here, I'm going to replace it with the number. Okay, so y equals 5, I know that. These two are the same, so that means every time I see a y, it can be replaced with a 5. So I'm going to replace the y with a 5. So 21 times 5 plus 3x equals 180. And now I can solve for x. 21 times 5, I'm not going to do that in my head. I'm going to use the calculator. 105 plus 3x equals 180. And again, that should be something that everybody can solve. You just subtract 105. So 180 minus 105 is 75. Divide by 3, and you get x equals 25. So I've got x equals 25 and y equals 5. So those are my variables. I know what they equal. I just have to plug them back in now to finish the question and get the answer. So again, you can plug each of those in. The x's just multiply by 25. So 2x times 5 or 25 is 50. So that one's 50. This one's 75. And then the other ones you multiply by 5. 26 times 5. I have no idea what that is. It's 130. And 21 times 5 is also 105. Okay. So now you have all four angles. Now again, this is a tricky problem because you have to remember algebra 1. And it's easy to forget that. But I will encourage you, if you're looking for something to study, this is a fantastic thing to make sure you have it in your brain. Systems of equations are notoriously popular on SAT questions. I guarantee you will see them. I can also tell you that they pop up all over the place in Algebra 2, all over the place in pre-calculus, all over the place in calculus. You're going to need to know how to do this, regardless of how far you go in math. The one exception is if you're taking Prob Stat as a senior next year, you won't need this for that. But In every other class, you will need it, and it will be important. It's not just like, hey, we have one problem here and there. That's one reason why geometry bothers me, that we don't spend more time talking about stuff like this. This is a really, really, really important problem to do. In fact, this is more important part of the problem than this is in terms of your overall math knowledge. So please don't brush it off and be like, okay, whatever, Calbeck just said this. This is important. You need to know how to solve a system, and particularly with substitution, because substitution always works. That's what we just did, by the way. This system where I substitute in a variable for a number, that's called substitution. Okay, we're going to do the same thing with problem 21.